Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 5 from section 5-2 in the SavvasRealize Algebra 2 textbook. The goal of this example is to multiply binomial radical expressions. That's a mouthful. So remember, binomial just means two terms, and then they have a radical, so binomial radical expressions. So here with part A, we have a number times a set of parentheses. So hopefully instinctively you're thinking to distribute, okay? And that's exactly what I'm going to do here. So I'm going to take the cube root of 7 times 2. Now I don't need to move that 2 into the radical at all. It's okay to keep it just out there, okay? But here where I do a radical times a radical, it's a little bananas for people still, right? Remember, in order to multiply radical expressions, they have to have the same index, which is that little number outside the radical. So I'm multiplying these together, and so what this is doing is this is allowing me to move the cube root of 7 and the cube root of 49 into the same radical. Now recall, 49 is the same thing as 7 times 7. So this is the cube root of 7 times 7 times 7. And this index of 3 is saying that it takes 3 of a kind to remove that number from the radical. So because I have 3 7s there, I can remove it from the radical. And so this would be my solution. All right, so now let's try another one. So this one, notice they're the exact same expression times itself. So another way you might see this problem presented to you might be like this. Okay, so remember, if you see something like squared like that, it's that expression times itself. Now when we do this, again, we're using the distributive property, but we just do it for each of these terms. So I'm going to take 2x and times it to each of these terms here. So 2x times 2x is 4x squared, and 2x times the negative square root of 3 is negative 2x root 3. Now I'm going to do the same thing, but now I'm doing it with this negative root 3. So negative root 3 times 2x is negative 2x root 3. And negative root 3 times negative root 3 is a positive. Root 3 times root 3 is just 3. And then our last step, y'all, is to combine those like terms. So right there in the middle, I have a negative 2x root 3 and a negative 2x root 3. So that is a negative 4x root 3. You might be saying, well, Missy, where are you getting that 4 from? Why isn't it like x squared or something? Imagine that x root 3 is the same thing as a y or something. So I have negative 2y minus 2y would be a negative 4y. Alright, so I'm combining the coefficients and not combining the rest of it. Now don't forget, I still have a 4x squared and I still have a plus 3. So that there is our final solution. Alrighty, so now we have this situation where it looks like an expression times almost itself, right? The signs are off, but everything else is the same. Remember, these are called conjugates. And what happens when we multiply conjugates? Well, stuff cancels out. We've learned that. Okay, it works the same way for radicals as it does for imaginary numbers. So let's check it. So I'm going to take the x and times it to each of these. So x times x is x squared. And then I'm going to take the x and times it times the square root of 10. So x times the square root of 10 is x root 10. And then I'm going to do that same process now with the negative root 10. So negative root 10 times x is negative x root 10. And a negative root 10 times a positive root 10 will come out with a negative, right? And root 10 times root 10 is a positive 10. Well, it's negative because of that negative, but together they make a 10. All right, and then we got to combine our like terms, right? So I have x root 10 and negative x root 10. Those cancel each other out. They don't combine at all. They just undo each other. And so what am I left with? I'm left with the x squared and the minus 10. So notice when I multiply together conjugates with a radical in them, the radical disappeared. So usually when we are looking at polynomials, right, we don't normally see any imaginary numbers and we don't normally see radicals inside of a polynomial. So we use the conjugate to get rid of radicals. You might remember from my previous video where I talk about how you can't have a party in the basement. So you can't have a radical in the denominator of a fraction. We use conjugates to get rid of them. All right, let's go ahead and let's do our last one. So again, this one's utilizing that distributive property, right? It's a monomial times a binomial. So I'm just going to multiply across. So here, the square root of 6 times 5 is 5 root 6. And here, remember they have to have the same index to multiply them, so I'm just going to put them all under the same thing. I have my 3 from here. And 6, I'm just going to break it up right away. 6 is 3 times 2. And if you notice, I have a pair of 3's chilling in there. So I can remove a 3 from the radical. And that is our final solution. So there we have it. That is how you multiply binomial radical expressions. Until next time.